All right, let's dive in. Today we're going to talk about a pretty fundamental shift that's happening in software engineering, all thanks to large language models. But this isn't going to be about hype. It's a straight-up, sober, technical look at how our jobs, and really where our leverage comes from, are evolving.
I want to kick things off with a statement that might sound a little provocative. Your AI progress might be an illusion. If you're an engineer shipping features with LLMs, that incredible bursts of productivity you're feeling, well, it could be masking some pretty significant underlying risks. We need to talk about why that is.
So here's our roadmap for today. First, we'll break down that illusion of progress. Then we'll get into the most critical part, the mental model shift from deterministic to probabilistic systems. After that, we'll see how this is moving engineering value upstream, talk about how to actually build the right skills for this new world, and finally, look at what it really means to architect for uncertainty.
All right, first up, the illusion of progress. For many of us developers, it feels like we're moving at light speed right now. And look, in some ways, we really are. But that speed, it can be dangerously misleading.
So what does doing AI look like for most of us right now? It's probably these things, right? We're wiring prompts together, connecting models to our existing tools, building some really impressive copilots and demos, and yeah, shipping new features at a crazy pace. And it feels awesome. It feels incredibly productive. And for a little while, it is.
But here is the catch, and it is a big one. You can get these amazing, wow results in a demo without having a deep, intuitive understanding of how these language models actually behave. And that disconnect, that's precisely where the danger is. A successful demo is not a safe, reliable, or scalable system. They are not the same thing.
And this brings us to what I think is the single most important mental shift for any engineer working with this tech. We spend our entire careers thinking deterministically. We have to start thinking probabilistically.
Now this visual really nails the category error that so many of us make. On the left, that's our home turf, deterministic APIs. Our bread and butter. You put something in, you get the exact same thing out, every single time. Then in the middle, you've got rule-based systems, still predictable. But all the way on the right, that's where LLMs live. They are probabilistic pattern engines. They don't execute logic, they sample from a probability distribution. This means the same prompt can give you different outputs. And that's not a bug, that's just what the system is.
Let's just make this crystal clear. With a normal, deterministic API, you've got a contract. The errors are known. You can build automation on top of it and sleep at night. With a probabilistic engine, like an LLM, there is no contract. There are only patterns. The failure modes are emergent, meaning they just pop up out of nowhere, especially at scale. You simply cannot automate these systems directly without putting a layer of governance around them first.
So here's a little reality check we all need to internalize. Just because a prompt worked once, that does not equal system correctness. The context you provide is fragile and super sensitive. Tiny changes can cause massive shifts in behavior. And maybe most critically, when you scale these things up, they amplify failures much, much faster than they amplify successes. So I'll say it again, governance before automation is not optional.
Okay, so once you really get that we're dealing with probabilities, not certainties, it leads directly to this next point, a fundamental shift in where we as engineers provide the most value. It's just not about pure execution anymore.
And this image, it just perfectly illustrates the core idea here. The work is not going away, not at all. What's happening is the center of gravity, where our real leverage comes from, is moving upstream. As things like code generation become more and more of a commodity, the real value shifts away from just implementing the code and moves toward architecture and, ultimately, toward system ownership.
Let's just look at this evolution of roles. You've got the implementer focused on execution, code, frameworks. In this new world, that role's leverage is basically capped. Then you move up to the architect. This is the person translating intent into system design and constraints. Their leverage is high because they're the ones who can direct and contain the AI. But the highest leverage, that belongs to the system owner, the person focused on outcomes, governance, and risk, the one who's accountable for ensuring the whole system is safe and auditable. This is just professional evolution.
Okay, so if that's the goal, to move up that stack and become an architect or a system owner, how in the world do you develop these skills? Well, the answer might be a little counterintuitive. Let's look at the right way to learn this stuff.
So where do you even begin? How do you build that gut feeling, that intuition, for how these probabilistic systems actually work? Well, the common mistake is to just wait around, waiting for your company to roll out the official enterprise stack with all the vector databases and orchestration tools. That approach is actually harmful to your learning because all it teaches you is tool integration, not model behavior. The correct starting point is to interact directly with a raw LLM, preferably a local one that isn't changing on you every week. That is how you build true systems literacy.
So here are your exercises. Get a model and just observe its variance. Give it the same prompt 5 times and see what happens. Test its sensitivity, change one word, one comma, and watch how the behavior shifts. Then actively try to make it hallucinate to understand its failure modes. And finally, track how one small error in a conversation can compound and completely derail the entire thing. This direct, hands-on experience is absolutely irreplaceable.
So once you have that literacy, once you built that intuition, then you can start to think about the final piece. How do you design systems that can safely contain and manage all this probabilistic behavior?
Now, I know this diagram looks complex. Don't worry about dissecting every single box. That's not the point. Instead, I want you to just look at the structure. See the clear separations, the control points. This is an example of a system that's been explicitly designed to govern a probabilistic core with deterministic rules, with a clear separation of concerns and with audit trails.
The principles here are what really matter. A governed system separates the intake of information from the model's authority to act on it. It separates its reasoning from its ability to actually execute. Generation is separate from execution, and this is a huge one. Automation is kept separate from autonomy. Everything that happens is explicit, it's logged, and wherever possible, it's reversible. You're not just letting the model run free, you're building a deterministic container around it.
And for anyone out there thinking, wow, this architectural rigor sounds slow, let's be really clear. This is not about being slower. It is about being correct and safe at scale. You can't achieve a scalable, reliable AI system through improvisation. You have to design for it. So let's end on this. If we want to build safe, non-trivial AI systems, the kind that become real infrastructure, not just cool demos, it requires a deep understanding of the system itself. It's no longer enough to just be the person who wires together the tools. The real challenge, and frankly, the real opportunity for all of us, is to become the architects and the owners of these new probabilistic systems.